So in this video, let us discuss about the derivation of thin lens formula. For that, let me consider a thin lens, a biconvex lens like this. Let this be the principal axis. And this point is the optic center O. And let me draw a mean line through this optic center so that I can take all the measurements from this mean line. Now there is a point F in here called the principal focus, and at the same distance, that is at a length equal to OF, there will be a F dash, a point F dash in here, that is OF equal to OF dash. Now if I place an object in here, let's say an object AB, and we know by the rules of the refraction through a lens, any ray which is passing parallel to the principal axis like this, after refraction passes through the principal focus. Any ray which passes parallel to the principal axis after refraction passes through the focus. And another ray, we have to draw two rays to get the image. That is, another ray which is passing through the optic center like this passes undeviated. Now these two rays meet at the point here and we will get an image here. Let's call that as A dash, B dash. Let's mark this point as some E. Okay. Now we are actually using the property of similar triangles to arrive this equation, that is the thin lens formula. For that, let me consider first the triangle BAO and B dash A dash O. That is, consider the triangle BAO and B dash A dash O, triangle B dash A dash O. Let me draw that triangle in here. This is A, B, O, and this is A dash, B dash. So this is the two triangles we considered. And we know this angle is equal to this angle, that is vertically opposite angles. And we usually consider the object as perpendicular, as placed perpendicular to the principal axis. So this will be 90. So this also will be 90. And we know if two angles are equal, the third angle will also be equal. Now we know the sides opposite to equal angles are in same proportion for similar triangles. That is, see, if two angles of one triangle are equal to two angles of another triangle, obviously they become similar. Okay. Now the side opposite to this angle is AB. So we have AB divided by, this angle is equal to this angle. So the side opposite to this angle is A dash B dash is equal to, now take this angle. The side opposite to this angle is AO. AO divided by the side opposite to this angle is equal to this one. So the side opposite to this angle is OA dash. Clear? Let me put that as equation number 1. Now consider another triangle. Now consider the triangle EOF and triangle B dash A dash F. B dash A dash F. If I draw this triangle, that is, this is E, this is O, this is F, this is A dash, B dash. Okay. Here also these two angles are equal and this will be 90. and the third angle will also be equal. Now, like we discussed before, the side opposite to this angle is EO divided by this angle is equal to this one. So the side opposite to this angle is A dash B dash is equal to, now take this angle, that is side opposite to this angle is OF divided by side opposite to this angle is FA dash. Let me take that as equation number 2. Now I can replace this EO. When you look at, replace this EO with AB. See, when you look at this diagram, we know AB is equal to EO. Clear? So this EO can be written as AB divided by A dash B dash is equal to OF divided by FA dash. Let me put this as equation number 2. Okay. Now when you compare 1 and 2, on the left hand side, both these equations have AB by A dash B dash. So the right hand side will also be equal. That means equation 1 equal to equation 2 implies AO by OA dash will be equal to OF divided by FA dash. This implies, let me change this FA dash. See, this is the FA. Let me write F here. This is the FA dash. So this length will be OA dash. Write the other side as such, that is AO by OA dash is equal to OF divided by this FA dash is OA dash minus OF. Clear? Let me consider this as equation number 3. Now let me write the different measurements, that is different lengths such as object distance, image distance, etc. in here. See, we have the distance of the object from the optic center. We usually take that as the object distance U, and the distance of the image, that is A dash B dash from the optic center, we take that as V. And we know the distance of the focus from the optic center as focal length F. Also one more point, all the measurements to the left of optic center, that is in this direction, is considered as negative, and all the measurements on the right side is considered as positive. Okay, that is according to new Cartesian system. So OA, we know OA is U, but that is on the left, so I have to write minus U. Clear? Divided by, see this OA dash is actually V. That is on the right hand side. So I have to write, I can take that as positive, equal to OF is F, that is also on the right, by OA dash is again V minus OF is U, sorry, F. Now I can simplify this equation. Let me cross multiply, that is U into V minus F is equal to F into V. This will become minus UV plus UF is equal to FV. Now take this FV to the left and UV to the right. It will become UF minus FV is equal to UV. Now let me divide. Before that, call this as equation number 4. Divide each term of the equation 4 with UV. You will get UF by UV minus FB by UV is equal to UV by UV. this u and u will get cancelled. Similarly, this v also get cancelled. So f by v minus f by u is equal to, this will be 1. Now I can take the I take f as common, so that this will be 1 by f into 1 by v minus 1 by u is equal to 1. Now take the f to the right. You will get 1 by v minus 1 by u, that is, I'm taking this f to the right, is equal to 1 by f. So this is called the thin lens formula. Clear? 1 by v minus 1 by u equal to 1 by f.